So energy is the ability to do work. And we divide energy up into kinetic energy and potential energy. Kinetic energy is the energy of motion. So if something's kinetic, it's moving. So this might be something like walking, a car rolling, water flowing, but it also might be something like a chemical reaction, like burning gasoline, or digesting food. Potential energy is stored energy. Sorry, I got a blot there. This would be something like water behind a dam. How about a compressed spring, or a car at the top of the hill? These things all have energy stored in them, but they're not moving. And a chemical example of potential energy would be energy that's stored in chemical bonds. And we would find examples of energy stored in chemical bonds in food or fossil fuels like coal or oil. Those things have energy stored within them, and that's a form of potential energy. So I said earlier to not confuse temperature with heat, but I didn't define what heat was. Heat is the energy associated with the movement of molecules. And so heat is kinetic energy because it's the energy of motion. We measure this energy with two different units. We use calories, which are confusingly calories and kilocalories, and joules. If you take physics, you'll use joules. If you take food science, you'll talk about calories. To convert between joules and calories, 4.184 joules, capital J, is equal to 1 calorie. And 1,000 calories will make up 1 kilocalorie. When you look on food packages and they tell you how many calories the food has, they're really talking about kilocalories. if you travel, I was in Iceland, and when you're in Iceland, the food packages and stuff tell you how many joules the food has. They don't tell you how many calories. So those are interchangeable, and we'll talk about how to convert. How many calories are obtained from a pat of butter if it provides 150 joules of energy? So we have joules. We have 150 joules. We'd like to know how many calories. On the last page, I gave you the conversion, the equality. 4.184 joules is equal to 1 calorie. That's the equality. We can use that equality to write conversion statements. So we want to start with 150 joules. And I put that on a line. I want to write a conversion statement so that joules disappears. We'll put the joules in the bottom and the 1 calorie in the top. My line's too long. Okay. Joules is going to cancel out here, and we're going to be left with calories as our units. And if you put this in your calculator, you get 36 calories. Okay, temperature. Temperature is the measurement of molecular motion. So molecules that are moving faster will have a higher temperature. Do not confuse temperature with heat. Heat is a type of energy, and temperature is just the measurement of how fast the molecules are moving. We use 3 different temperature scales. In the United States, we use Fahrenheit. Water freezes at 32 degrees Fahrenheit, and it boils at 212 degrees Fahrenheit. Normal body temperature is right around 98.6. In lab, in chemistry, we mainly use Celsius. On the Celsius scale, water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. And normal body temperature is the 37 degrees Celsius. Make sure we put all our units on everything. Kelvin is, we also will use Kelvin. And Kelvin is a very interesting scale because the 0 on Kelvin is equal to the coldest temperature possible. At 0 degrees Kelvin, all motion stops. So water freezes at 273 Kelvin. There's no degree. Water boils at 373 Kelvin. To convert between Celsius and Kelvin is pretty simple. You just take the Celsius temperature and add 273. And we'll be doing this a lot when we get into gas laws. So what is the formula? These are the formulas that we'll use to convert Celsius to Fahrenheit and Fahrenheit to Celsius. So let's work a couple of examples to make sure we know how to do this. A person with hypothermia has a temperature of 32.8 degrees Celsius. What is this temperature in Fahrenheit? Okay, they've given us the Celsius temperature, so we want to use the formula up here that has Celsius in it and has Fahrenheit as the answer. So the Fahrenheit temperature is going to be equal to 1.8 times the Celsius temperature, which was 34.8, plus 32. And the answer you get if you do that is 94.6 degrees Fahrenheit. A pepperoni pizza is baked at 455 degrees Fahrenheit. What is that temperature on the Celsius scale? Okay, well then for this one we'll need to use the other formula. They've given us Fahrenheit and we would like to have Celsius. So the temperature in Celsius is going to be equal to the temperature in Fahrenheit minus 32 divided by 1.8. So the Fahrenheit temperature was 455 minus 32 divided by 1.8. And that will give us 235 degrees Celsius. So here's two more problems. I want you to try them first. So stop the video and try and work the problems and then come back and I'll show you how to do them. Did you work? Did you stop it? Okay. On a cold winter day, the temperature is minus 15 degrees Celsius. What is the temperature in Fahrenheit? So the temperature in Fahrenheit is going to be equal to 1.8 times the temperature in Celsius plus 32. That's the formula. You will always be given that formula. I am not big on having people memorize stuff. I will give you the formula. So we'll have 1.8 times minus 15 plus 32. And our answer here will be 5 degrees Fahrenheit. And what is the normal body temperature of 37 degrees Celsius in Kelvin? Well, if we want the temperature in Kelvin, we take the temperature in Celsius and we add 273 to it. And so 37 plus 273 gives us a normal body temperature of 310 Kelvin.